Hello everyone, my name is Houston and I'll be taking you through the high school physics course. The focus is on A level and grade 12. First question we'll be answering is, what is physics? Physics is defined as the branch of science concerned with the nature and properties of matter and energy. The subject matter of physics includes mechanics, heat, light and other radiation, sound, electricity, magnetism and the structure of atoms. That's a lot of words. That it's so difficult to even know what it means. But do not worry, in this course there's going to be theory, but I'll try boil the theory down into practical examples. Examples like physics is involved in calculating how the earth rotates around the sun. For us to know that, it's helpful because we want to know when it's summer and we want to know when it's the rainy season. If we know the rainy season, we are able to tell farmers when to expect rain and how much rain they should expect. They are able to plan how to plant their crops, the amount of fertilizer they need, irrigation, all those things. So now when we go to the shops to buy food, the food is there because it all starts off with physicists sitting in weather stations calculating how the sun is going around the sun. Also, knowing how the skeletal system holds up a human body. How does that help us? Because some people lose their limbs, maybe in an accident or whatever it is, and you can see right now these days they are creating artificial limbs like prosthetics. You cannot just create a prosthetic without understanding how a human body functions. How does a person move? When you understand the motion of a human body or a human skeleton, you are able to create a prosthetic that will mimic that motion, right? Makes sense, isn't it? And back in the day, Henry Ford, when he invented the car, he needed to understand how an engine will work. He needed to invent some of those things. There's combustion, there's exhaust. How do you take out the exhaust? How do you make it efficient? How do you increase the power? How do you increase the speed? All of those calculations, physics is involved in all of those calculations. Why is a Lamborghini faster than a VW? The way they manufacture their engines is different from the way VW does it on a Polo, right? And those power calculations, you can do them in physics and balance them out. Try to see how can I increase my power or increase my speed, or how do I increase my do I decrease my braking speed? How do I make sure that it stops within a few meters? All those things. Physics is involved in that. So you see, it's involved in our safety when we're driving our cars, in our comfort and everything like that. Also, physics is involved in knowing how sound travels through air, right? Why can you hear me right now? There's someone who invented the speaker that you're using. There's someone who invented this microphone that I'm using. But for them to invent these two instruments, they needed to understand how sound travels through air, right? How can it go from my mouth to the mic, and how can it be recorded on this video? And when you play this video, how can it travel from the video to your ear? So they needed to understand all those things, like how does sound travel. Also, if you know things like those earpieces that partially deaf people use, they're developed in such a way that it enables the person to hear sounds. But for them to do that, they need to know how to capture the sound. That's all physics. What about your eyes? Your eyes can see right now. Maybe you're wearing glasses. Why are you wearing glasses? It's because probably you can't see properly, right? If you cannot see properly, physicists understood why an eye cannot see properly. It's because an eye has a lens. But that lens sometimes it does not refract. It's called refraction. We are going to see it when we do optics. It does not bend light enough for you to see a clear picture. So physicists were like, nah, we are smart. We can create artificial lenses, those glasses. But for each person, they will have a different lens because physics allows us to calculate by how much is the natural eye lens failing so that we can give you the right lens on the glass. So all those calculations, physics, and we're going to see them later when we do optics. Electricity. Right now you wouldn't be watching this video if it wasn't for electricity. Physics allows us to calculate the amount of electricity that is going into my laptop right now, all the way up to how it was even generated with the hydroelectric power or coal power or nuclear power. All that is used physics is involved in that whole chain. What about people that are going to space? We hear that people want to go to Mars. That is one of my dreams, to be honest. I would love to do space travel. I would love to go to Mars. I would love to go to other stars. All those calculations are physics. But what they are concerned about right now when it comes to going to Mars is radiation. How are the people going to survive that journey when they are not in an atmosphere? Because we know that our Earth covers us from sun rays because of the atmosphere that is around us, right? But when you're out in space, you do not have that atmosphere. You're exposed to direct sun rays, like radiation. So physicists right now are calculating that radiation that people will be exposed to when they go to Mars. Physics is involved in space travel. Of course, because space travel is physics, but you get what I mean? Physics is all around us. From everything, like the way you're sitting right now, physics can be used to calculate that. So in this course, it's going to be structured like this. The first part is going to be mechanics, properties of matter. That's dynamics, circular motion, gravity, elasticity. Inside each of these points, there are other subtopics we'll be doing. Like under dynamics, we have velocity, we have forces, we have momentum, we have energy, and all of those things. So these are not the only topics we'll be doing. Inside them, there are other videos that will be included. Second part is going to be heat. Third part is going to be optics. And the fourth and last part is going to be electricity, where we do current, electricity, AC, DC, magnetic fields, electrons, radioactivity. My advice for this course is think outside the box. Think outside the box. Know that physics is all around you. Like I said, the way you're sitting, why aren't you not sinking into your chair or your bed or wherever? You're not sinking because the bed or the chair is reacting with an equal and opposite force. We are going to see that later when we do Newton's laws of motion. But you're not sinking because of physics. Physics can explain why you're not sinking into your couch, into your chair. We can explain all that using physics, right? Or when you walk, when you call someone, how can you call someone? How can you communicate using a cell phone? All of that can be explained through physics, and it was actually developed using physics. Electromagnetism. Those are electromagnetic waves. So all that stuff involves physics. And the other important part, that is the first pillar. The first pillar of this course, let's just think outside the box. And let's translate the theory into practical examples that we can see every day, right? And the second part is, let's just have fun. Physics is fun. It's all around us. You can see right now when you're looking at this video, physics is involved. It can explain how you can see that video. How can you see this guy who's so happy because of physics? You see, so it's all around us. So let's just have fun. In the next video, we're going to start the first section, which will involve dynamics. So stay tuned for that.